In the last video, we figured out for these two polynomial functions, what is the sum function, difference function, product function, and quotient function. In this video, I wanted to talk about using those and actually what stuff like domain and evaluating. So number 2 says to evaluate each function at 5 if possible. And that's just kind of a way of saying, well, each one of these creates a new function by combining them together using the different 4 mathematical operations. But basically, let's say we wanted to evaluate them at 5. Basically, each one creates its own new function. So f plus g of x is, we've just solved what that is. And now what I could do is actually plug in 5 into it. And just to reiterate, this notation is a way of saying, well, normally we have f of x notation, which is describing as, well, we have an input and we're plugging it into the function f itself, defined by this. And the notation here is the same idea, f plus g of x. Basically, again, this is not an algebraic statement, this is function notation, which is a way of saying, well, I've combined 2 functions together in one, but I'm still evaluating those functions at x. And if you're thinking about the distributive property here, this would kind of be f of x plus g of x. But again, you don't actually multiply this all through because this is not an algebraic expression, this is function notation. And so this is just a way of saying I have a new function called the sum function, and it's defined over here. So when I see something like this, this is not saying, well, technically what I could do is what is f of 5 plus g of 5, because that would be the same result. But since I've already calculated and simplified the sum function, I can just use this formula and figure out, well, what is f of g, or f plus g of 5? That would just be plugging 5 into the function. And since I found that it was x squared minus x plus 2, all I need to do is replace x, the generalized x, which is the input here, with 5. So I replace all the x's over there with 5. And so this would give me 25 minus 5 plus 2, which is, of course, 22. And that would be my, basically using this new function that I have created by adding them together and actually plugging in 5 into it. And again, you can plug in whatever number you want into there, and it would be totally fine. And I could do the same thing with f minus g. F minus g of 5, well, that was this function right here, x squared minus 3x plus 12. So I'd have 5 squared minus 3 times 5 plus 12. Well, that would be 25 minus 15 is 10 plus 12 is also 22. Now that is actually a heck of a coincidence, because usually you would not get the same result when you add and subtract at a different value. But in this case, notice that if I plug in 5 into g, it's actually 0. So whether I add, g of 5 was actually 0. So f plus g and f minus g didn't actually make anything different in this specific case. But in general, these would be different answers. Now f times g was this function over here, x cubed minus 7x squared plus 17x minus 35. And if I wanted to evaluate at 5, again, I could write that as fg of 5. And again, I could plug it into each of those separately and multiply that result together, or use the product function, which I simplified before. So that would be 5 cubed minus 7 times 5 squared plus 17 times 5 minus 35. I'm now wishing I picked a little bit less obnoxious numbers to work with, but it's too late. 5 cubed is 125. 5 squared is 25 times 7 is 175. I'm going to go ahead and erase this over here because I don't need that anymore. I used that for the last example. 17 times 5 is, 10 times was 50, 20 is 100. So that should be 85, I believe, plus 85 minus 35. And I'm pretty sure this is going to be 0 just because I already know f and g, I was talking about what just g of 5 alone would be, but let's go ahead and make sure. This would be negative 50 plus 85 is 35 minus 35. Yeah, that indeed is exactly 0. But that's just because g of 5 was 0, and anything times 0 is going to be 0. But of course, you could just do the math once you have the combined function. And last but not least, I could try, well, what is f divided by g of 0? Or sorry, of 5, I mean. And that would be, well, using this function. I could use either one, but since I went ahead and computed the result of the division, let's use this form. So that would be 5 plus 3 plus 22 divided by 5 minus 5. And notice in this case, this creates a problem because 5 divided by 5 is 0, and dividing by 0 is not allowed. So basically, we get an error or something undefined, however you want to write it. But basically, this value does not work. And again, as I was saying, a couple weeks ago when we were talking about functions, any value which does not work within a function is not within its domain. So in some cases, we have a problem when we're, and specifically that happens when we're dividing. And that's just something to be aware about. If you're dividing polynomials, you can create undefined values because of division. With the first three polynomials, it's impossible for there to be anything undefined because they're just polynomials and their domain was all real numbers. But once you start dividing stuff, you're actually creating mathematical problems, and sometimes we get stuck. And this leads me into number 3 on the packet for this week, which is determine the domain of each function. And that's kind of what I wanted to wrap up with from this example. Well, the domain of f plus g, when you add two polynomials together, you get another polynomial, right? And a polynomial has a domain of all real numbers, so that stays the same. Basically, the domain of f plus g is all real numbers. Domain of f minus g is also all real numbers, and same with f times g. They're all the same, because whenever you add, subtract, and multiply polynomials, you get another polynomial. The difference is when we divide polynomials, we get something which is no longer a polynomial. And remember, I said this in class, but I talked about a lot of different things in class this week. But that's when you're dividing by x, it's no longer called a polynomial, it's something different. And that division is what causes it to be a little bit weird. But in summary, there's only one problem with this particular, if I'm looking at the quotient to the division, x plus 3, this has no problems. The domain of this part is all real numbers. But since there was a remainder, and since there's division in general, this is what causes the problems. And of course, that would occur when the denominator is 0. So if we set this equal to 0, x minus 5 equals 0, and add 5 to both sides, what I would get is that x equal 5 is the problem. And we already kind of figured that out from the last example. But all that being said, there's only one number that will not be allowed in f divided by g, and that's when the bottom is 0. And so the domain of f divided by g, or the quotient function, would be all real numbers except for minus 5, because there's one problem. Any other number, like 2, 7, negative 3, will work all fine and well and dandy, because in general, anything works in a polynomial. The only thing that does not work is when you divide by a polynomial, the denominator is not allowed to be 0. So again, we could write this as negative infinity to negative 5, negative 5 to infinity, because there's only one value that does not work on our number line, which is negative 5. And this just kind of means put an open circle on the negative 5, and everything else, everything less than negative 5 and everything greater than negative 5. Sorry, why am I saying negative 5? It was positive 5 that didn't work. But my point still stands. Everything else is fine. Now, these same ideas can be applied to other functions other than polynomials, but the general idea of this logic is true. And the one thing, is if you are dividing mathematical functions, you just got to be very careful that the second function is no longer allowed to be 0. Even though, in the initial setup, g of 5, that's totally fine. G of 5 is 0. There's nothing wrong with that. But since we're dividing by g, that's what's causing this gap within the domain.